Okay, everybody, I've been requested by a few people to make a video about what happens when you put your video antenna over ground, similar to the video I made where I compared the folded dipole, the stock dipole, and the 5 dBi mod for the Tyrannus. So I'm going to do this here for the video, and I'm going to go over a couple of different antennas. The first is the Ion, and you can see I've got the Ion here, and I've got it modeled in free space. I've taken away the circular grasp because it makes it really confusing, but I want to note something right here. You can see that I've got the horizontal and the vertical gain rather than right-handed left-hand, so keep note of that. You could tell that the vertical gain is greater than the horizontal gain on the horizontal plane, but look what happens. I've got a little bit more gain up here in the horizontal direction. Just an interesting way that the Ion turns out. And just so you know, this actually means that it will work better with a linear antenna than most circular antennas will, so kind of like that effect. But to try to keep this program from crashing, for some reason I can't go in and just modify the height over ground. So I'm going to open up a different file in here. You can tell I made quite a few different versions of the Ion, different models. And I'm going to open up this Ion over ground. And the way it is here, I have this factor called rise. Now, if I click on it, it's going to crash. But this is how many millimeters over the ground one of the users had told me he sits. And this is about 41 inches. Actually, I think it's exactly 41 inches. So if I simulate that, you can see here's the Ion over the ground. We simulated 5800 megahertz. And there was the pattern. Let's see if I can't get it back here. Boom, there's the pattern there, and there's the pattern here. So what you're seeing is a pretty good gain. I went from 2.35 or 2.5 dB on the Ion over free space to 6 dB. You can see right along the ground, you're not losing pattern into the ground. In fact, it's driving it up and increasing the gain significantly. Look at this, 6 dB. It's very uniform, not very erratic. No real nulls except for where we expect them over the top. And of course, you know, this is a pretty significant gain, 4, 5 dB, 3 dB at the 30-degree azimuth, so it's going to hold on pretty strong. Now I'll go back in here, and of course, I'll change that height and redo this. Okay, so here we could see I changed the rise, that is the height where the antenna here is over ground, to 1803, and that's 71 inches. That's what the first request that came to me was about, so let's get out of that and let's run our simulation, generating at 5800 megahertz, and see what this thing now looks like. The pattern is definitely smoother, but it's the same gain. So looking at it here, multicolor, a small change in the shape, definitely smoother. Looking over here, yeah, I mean, roughly the same gain all the way through. We can just tell less erratic shifts of the horizontal and vertical. And let's see what, just out of curiosity, let's see what happens when I rotate it. If you notice, I'm rotating this down here, effectively rotating the pattern, and it's really not changing. And that just tells me that this is a lot more stable than most antennas. So now I'm going to try with another popular antenna, the TBS Triumph. Okay, so here's the TBS Triumph, and I found out that there's something wrong with my simulation. I have no idea what's going on, but you can see the structure of the TBS Triumph, and yeah, I'm just going to chalk this up to a fail because watch what happens when I try to simulate it over ground. It just, for some reason, this is just not working. Let's see where did I put that stinking file? Triumph foamed. Uh-oh. Ah, there we have it. Triumph over ground. Look at this stuff. I don't know why it's doing this, but it just pushed the elements way too far away. And this is where I'm just going to show you what happens. This is why antenna design is actually important. Look at what it does here. Yeah, that is just, wow, that's erratic. This is why you can't just throw antennas in any random orientation, because stuff like this can happen. I mean, that is just not usable at all. And perhaps later I'll make a better video where I can figure out how to actually put these where they belong, which is right here. So maybe we'll just move on to the Airblade. Okay, so here we've got the Airblade. I'll zoom out a little bit so you can see the structure. You can see that's the Airblade here, again modeled in free space, gain of 1.76. So we're going to change it up and let's see what it looks like over ground. So if we open it and we put it over ground, again, you can see I've had a lot of different versions of this. If I put it over ground, again, we're going to go that 41 inches that was requested of me right here. Of course, this is in millimeters. So we'll go out here. We'll run a simulation at 5800 megahertz and see what it looks like. All right, show multicolor. And we're going to get this up here. Okay, so not as smooth as the Ion, but not bad. Slightly lower gain, not by much. Still pretty erratic. Some pretty big nulls in here. Not terrible. That one right there at the 60 degree azimuth is kind of nasty. But overall, not bad. You know, if you're using circular polarization, you're just going to get this outer shell here. If you're using linear, well, it's going to be a little erratic depending on the orientation of your vehicle. So overall, not bad. So let's see what happens when this is, of course, with the Pilot sitting. This is a 41 inch. So let's see what it looks like with the Pilot now standing. Okay, so here we've changed the height to 1803 millimeters, and that's approximately 71 inches. Again, same Pilot, now standing. You can see the antenna has moved up here significantly higher. So let's run a simulation and see what this looks like. So show multicolored pattern. Let's zoom out a little bit. It seems a lot smoother down here. Let's see what this shows. Okay, definitely smoother in the low range. So low altitude, definitely smoothed out. Not quite as high gain as the Ion, but about the same as with that Pilot sitting. But it's a little bit more erratic, not a whole lot to linear. Again, circular, if you're running circular on the vehicle, you're just fine. And still even reasonable gain at the 25 degree azimuth, so out over here almost above yourself, though obviously a very pronounced null straight above, which is to be expected. And if I rotate this a little bit here, yeah, it doesn't change very much. The Airblade is quite stable. So on the 3D scale, you can see just a little bit of a weak spot right here. Not too much to be worried about. But overall, a significantly higher gain. So guys, you don't lose half of your signal on an Omni into the ground. It actually just amplifies the signal and turns it into something like this. And I want to thank Paul Vallejo. He is the one who asked me to do this. And of course, he is the Pilot that I was referring to through this video. He wanted to know what his radiation pattern looked like with sitting and standing, and I did too. Sorry, Paul, I couldn't get the Triumph to work for some reason. I'll have to go back to my program and revisit that. But for the rest of you, this is what happens when your antenna is close to the ground, on your goggles. You get increased gain. So it's not all bad. It's actually quite good. And so now you know what happens. I might be crazy, and keep 'em flying.